So now we're going to look at Learning Target 1.5 from the Unit 1 test. When I'm solving an inequality, I do the same steps as solving an equation with one exception. If I multiply or divide both sides of the inequality by the same negative number, I have to reverse the inequality symbol. So if this were the equation 2x minus 7 equals 5, the first thing I would do is to eliminate this constant on the left, I would add 7 to both sides. I'm going to do the same thing. Now I'm not going to put an equals between these like I would typically on an equation because then I might forget to change it back to an inequality. So I might very lightly do a dash line just so I have the what I do to one side I do to the other and I can double check myself. I'm going to end up, oops, sorry about that. I'm going to end up now with 2x, and let me change the color. 2x is still greater than, because I didn't multiply or divide both sides by a negative, and then 5 plus 7 is 12. At this point, with a single variable term on the left and a single constant term on the right, to isolate the variable, I would divide both sides by 2. Since I'm dividing by a positive 2, the inequality symbol stays a greater than, and I end up with x is greater than 6. Now, on the number line, I need to have 6, and I'm going to do this exaggerated circle where 6 is on the number line. I'm going to shade in parts of the number line that make this inequality true when I substitute them back in, because those are the solutions to the inequality. Well, when I substitute 6 itself in, 6 is not greater than 6. So I don't shade this circle in because it's not actually a solution. But numbers that are greater than 6 lie to the right of 6 on the number line. And then I also need to put another number in there that fits that description, such as 7. Again, this is like a two-step equation, only it's an inequality. I might, if I want to, do that little dash line, light dash line down through to make sure that what I'm doing to one side, I'm doing to the other side. To eliminate this constant on the left of plus 8, I would subtract 8 from both sides of the inequality. Addition or subtraction never flips the inequality symbol, so it's still less than or equal to. And I end up with 3x is less than or equal to positive 12, because 20 minus 8 is 12. At this point, I have a single variable term on the left and a single constant term on the right. So to isolate the variable, since it's being multiplied by 3, I would divide both sides by 3. Once again, I'm dividing both sides by a positive number. Even if this 12 was negative, the thing that I'm dividing by is positive 3. So the inequality symbol stays the same, and 12 divided by 3 is positive 4. So on my number line, I need positive 4 on my scale, and I need that exaggerated circle. Now, if I put 4 back in here, I get a true statement. 4 is less than or equal to 4. It's not less than, but it is equal to. And basically it's saying if it fits one of those two descriptions, it's a solution. So in this case, I want to shade in that exaggerated circle that I did. And then numbers that are less than 4 on the number line are to the left of 4. And an example of one of those numbers is 3. And I do need to have both of these on this number line. And last but not least, I have this inequality, still like a two-step equation, only a two-step inequality. To eliminate this constant on the left, I would add 5 to both sides of the inequality. Addition or subtraction never makes me reverse the symbol, so I end up with negative 4x is greater than or equal to positive 12. At this time, though, to isolate the x, I need to divide both sides by negative 4. As soon as I divide both sides by that negative 4, I have to flip the inequality symbol, and this greater than or equal to becomes a less than or equal to. So x is less than or equal to negative 3 is my answer. To graph those solutions, again, I need negative 3 with this exaggerated circle. When I substitute negative 3 back in, it is a solution because negative 3 is less than or equal to itself, because the equal to works. So I shade in the circle. Things that are less than negative 3 are to the left of negative 3, such as negative 4. Don't forget to put that number there. That is also a solution. That is Learning Target 1.5 on the Unit 1 test.